Good day, everyone. This is Emmanuel Science Academy. So it's been a while. So what do we have today? Graham's law of the rate of diffusion. Graham's law of the rate of diffusion states that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of their vapor densities or relative molecular masses. So Graham's law states that the rate is inversely, you know that this is the sign of proportion, is inversely proportional to what? Square root of their vapor densities, or rate is inversely proportional to the square root of their relative molecular mass. So we have a formula called rate is equals to volume over time. So we must take note of that. Rate is equals to volume over time. So let's break this one down. Rate is inversely, that is equal to K1 over square root of their vapor densities, or we can say R is equals to K over square root of their relative molecular mass. So in case we have more than one rate, we will say rate is equals to, you know, this is 1 over 1 divided by square root of what? D. Let's say this one is R1, which is rate 1, and this one is R2, and we have D1 and D2 here. So we say R1 over R2 is equals to 1 multiplied by, so if this sign of division change to multiplication, you know that what is in this place is going to come up and that up is coming down. So is equals to D2 over D1. Or the same thing is applicable to this place. We can say R equals to square root of M2 over M1, rate 1 over rate 2. So now if we are giving rate 1 and rate 2, they can say we should calculate the vapor density, or at times we can calculate the rates and we have been given the vapor density. Likewise, this molecular mass, they normally give us this molecular mass. At times we can calculate the ratio of this rate, or we are not given the ratio of this H, we are just given the relative molecular mass. These are the formulas in which we have to take note if we want to solve Graham's laws of the rate of diffusion. There are times in which it won't go like this. There are times that it will be what? Rate 1 over rate 2 equal to square root of D1 over D2, or R1 over R2 equals to square root of M1 over M2. So in the next video, I'm going to talk on that very well. So now the rate is inversely proportional to the square root of their vapor density or the square root of their relative molecular mass. And what do we have to take note? We have to take note that rate is equals to volume over time. So I'm going to solve questions in the next class. See you in the next class. Thank you. God bless you.